write out our original formula sheet, right?
Yeah, they're all there. Do you want to go through any of those questions?
Yes, sir. I just found something too because I didn't print it off. I was just looking on the thing on the. Could you go through question 4 if that's okay?
Yeah, that's on page 304.
Yeah.
Yep, sure thing. Okay, 25 kilogram object moving with a velocity of 3 meters per second to the right. So I'll make right positive, so 3 meters per second to the right. Collides with a 15 kilogram object moving to the left at 6 meters per second. So a negative 6 meters per second there, right? Find the velocity of the 25 kilogram object after the collision if the 15 kilogram object continues to move left but only 0.3 meters per second. Okay, so my V2 prime, oops. So in A, my V2 prime is it keeps moving left at 0.3 meters per second, so that's negative 0.3 meters per second. So M1 V1 times M2 V2 equals M1 V1 prime plus 15 times minus 0.3, because that's V2 prime. So far, so good? Okay. Yes, no, okay.
Why did you do 0.3?
Because it gives it to us in A, it says continues to move left, but only at 0.3 meters per second. Okay?
Oh, sorry.
Does that make sense? Okay?
Yeah.
All right, so I have 75 minus 90 equals 25 V1 prime minus 4.5. So I've got minus 15 right? Add 4.5 to this, that's minus 10.5 meters per second is your V1 prime. Oh, sorry, that's not right. Is 25 times V1 prime. Now I have to divide by 25. So I take 10.5. So I end up with minus 0.42 meters per second. So what is that telling us? Brendan, what's that telling me?
That it's backtracking. It's going back from the direction that it came from.
Yeah, perfect, Rory. That's exactly right. So one's going this way, the other's going this way. After they collide, this guy's going this way, this guy's going that way. That's what's happening here. All right, they both hit, and this one has greater momentum than this guy. Therefore, it's going to move it backwards. Now, just looking at the start of the question, this guy has 75 kilograms meters per second of momentum. This guy has 90, and they're moving in opposite directions. So it should make sense that when they collide, that the one with the larger momentum is going to move the other one with the smaller momentum. That would make sense for this question. Okay, so that was A. B says it rebounds to the right at 0.45 meters per second. Okay, so now in B, so I still have the same M1 V1. Now my V2 prime is 0.45 to the right. Okay, so we do it all again. 75 kilograms meters per second minus 90 kilograms meters per second equals 25 V1 prime. And then I have add, okay, 15 times 0.45, like that. Okay, so the difference being my V2 prime in this case is now in a positive direction to the right. So I have negative 15, subtract 15 times 0.45 equals minus 21.75 kilograms meters per second equals 25 V1 prime. Now my V1 prime equals that. So again, what's happening here is same thing. This is going this way. That's going that way. This guy is going to go that way, but this time this guy is going this way. So this time they both bounce off of each other and go in the opposite direction. So that's B. Go ahead, Brendan.
Yeah.
That all good?
Yeah.
Okay. And then in C, so we do it all again. And in C, they now stick together and move together. So that changes things a little bit as well. So now I go 75 kilograms meters per second, subtract 90 kilograms meters per second is equal to, now I combine their masses together to get 40 kg, and their velocity is going to be the same because they're sticking together. So now I have minus 15 kilograms meters per second. Oh, making a mess of this. So I take 15 divided by 40, and it's 0.375 meters per second. So they're both going left now. So it starts like this, and goes like that. They move back, going in the opposite direction. All right? Brandon, is that good?
Yeah. Sorry, do you mind moving out of the way for a second?
Yeah, go ahead.
Yeah, thank you. Yeah, it's just basically, it just shows basically what happens in different variables, like whether they stick together, whether they don't, whether they bounce, right? So.
Yeah, it's all based on the direction that the direction that they give us for the one ball, whichever way it goes. All right. But what you're basically understanding, the biggest thing to understand is that when the momentum is greater, you know, for the negative one here, it means that it's going to overpower the other one, right? So larger mass, larger.
Overpower, right? If it has greater momentum.
Right. So you notice that in every one of these questions, the one on the left, the 75 kilogram meters per second one, always ends up going left no matter what.
Right.
Okay? And that's based on the information given for the second ball. Okay? All right? And I didn't ask you to do 6, so I just said to do question 5, and then the two questions I think on, yeah, questions 3 and 4 on page 314. Okay? All right? And actually, the question 4, I'm not too
questions 2 as well, 2 and 314 as well.
Yeah, just do question 2 and 3 on 314. Don't do 4.
2 and 3. Okay.
Yeah. Come to think of it, you could do 1 as well. So do 1, 2, and 3. I did do 2 with you yesterday, but do 1, 2, and 3 on page 314. So if you finish those up for Monday, go ahead.
Yeah, I definitely remember how to do like 1. We definitely did that one last year. We had to find the differences.
Okay. Okay, so what I'm going to do then is give you that for the weekend, and on Monday I'll give you the assignment on momentum. Something that you can hand in fairly quickly. It'll be 5 questions, maybe 6 questions on momentum. All right?
Yeah. Basically, the sooner the assignment on momentum is, that's good. Because I can do all these pretty well, I think, anyways.
Okay. Yeah, so I'll get those done, and I'll get that to you Monday, and then Tuesday we'll start working energy, and we'll try and get it finished by the end of next week. It's not going to be easy, but we'll get the content's easy, but to rush through it and then get one more assignment would be ideal before your cutoff dates. Okay. Basically, what we've seen or I've seen up to today is that June 9th is the last day that I can really assign anything. So that would be.
Technically, it would be.
Yeah. All right. Any other questions this morning for physics or pre-calculus?
Not really. So just for pre-calculus,
finish it.
Check away at 1 again.
Finish the assignment, and then once you've done that, go through chapter 1. Just that chapter 1 is all on transformation, so it should seem like a breeze now. That's what I said to you in the start of the year. You're gonna look at this.
Terrible, but now it's easy.
Right. So if you got another assessment on it, you probably do pretty well. So it would be in our best interest to get that done as well next week. Get an assignment on it. Okay? Okay. Rory, anything?
No. I wouldn't be surprised if I got worse on the chapter 1 now, though.
You shouldn't. You're going to see that it's easy because you've been doing it in every section so far. It's just on all the graphing. Okay. You guys need anything else from me?
No, that should be good.
All right. Okay. Well, enjoy your weekend. Let's get this stuff done for Monday, and we've only basically got about 7 or 8 more days to go. All right?
Jeez. Good.
Yeah, it's...
Have a good weekend.
Okay, you too. Thanks a lot. See you guys. Bye.